All right, welcome back to Integrative Project Management. This is the second lecture of Unit 5. So, last time we talked about how we don't just want to think about our project in 6-month intervals, or think about like the first year and then not worry about after that. So, we talked about how maintenance is an important part of making your project go for many, many years. Sometimes we build these roadmaps that show that we want to do things over a year or 2 years or 5 years or even longer. Sometimes projects can be very big and have sort of a long-term vision for both the project itself and for the consequences of the project. So sometimes the project isn't just kind of this thing, self-contained thing, but it affects the outside world. Other times the project runs for a long time, and we talked about how sometimes some projects are sort of time limited to 2 to 5 years. Other times projects go longer, and you have to manage those projects appropriately. So I'm going to give a couple of examples of how projects are a series of goals over many years and contributions. So remember, your project isn't just like setting up an application and then putting it out into the world and then forgetting about it. You're sometimes working on a number of goals over many years. So you might have an application where you have 2 or 3 features, and then you might add features every 6 months for like 10 years. And at the end of 10 years, you've added a number of new features to your project. You may have removed some features, and that project evolves accordingly. Sometimes you have people who move into your project, move out of your project, and you have to be able to deal with that accordingly as well. This is an example of one project where they took sort of a long-term view, and it isn't just about like the length of the project. Because the length of the project wasn't that long, it was that the effects of the project or the outcomes of the project would be sort of this long-term thing. So the Manhattan Project, the LinkedIn article that talks about this. So the Manhattan Project was the race to develop the first atomic bomb. This project was under military control, it was highly secretive, and you had to have clearance to work on the project. That being said, thousands of people across multiple sites were working on a shared goal of building the first atomic bomb, and they were trying to do it in a timely manner. They were competing with the Nazis to try to make sure that they didn't get the bomb first. They were trying to, they were in this time pressure where they had to get this thing done in a certain amount of time. They had to solve a lot of problems that involved thousands of people, many, many teams, all working to make this happen. They also managed multidisciplinary collaborations of physicists and chemists with clear unified goals. So, if you've ever worked with a physicist or chemist, you know that they don't bend easily to authority, especially when they're right. So this is something that that's a challenge in any project, but especially in a project like this. And of course, to do these kind of multidisciplinary collaborations, you need to have clear unified goals. If we go back to our examples from Sinofin, where we have those regions of problem type. We have the clear, the known, the knowable, the unknown, and the unknowable. And a lot of the problems that they were dealing with here are either in the unknown category or in the unknowable. And so you had to figure out what problems you could solve, how to solve them from scratch. Sometimes you had to invent things to make things happen, and then apply them to this end goal, which was building this bomb. This, of course, also required effective leadership and decision making. So this is one example of a project where it was huge. You had to manage a lot of resources. You had to make that sort of management structure sustainable across many different collaborators, many different sorts of scenarios. And then there was a long-term aspect of this, which is that then you had a bomb that you had to manage the production of, the maintenance of, and so forth. Another example is the Human Genome Project. So the Human Genome Project was an attempt to produce a draft human genome. This was back when genome sequencing was very expensive and very hard to implement. And so they wanted to do this, create a human draft genome for medical applications and make it public for researchers and to speed up the process of how to sequence DNA. This project lasted from 1990 to 2003. And it was an international team sponsored by the DOE and the NIH. These are American organizations, science and energy organizations. They sought to not only sequence the human genome, but other genomes as well, such as E. coli, Drosophila, melanogaster, which is the fruit fly, C. elegans, which is a nematode, and mouse. And the reason they did that was that so that they could, they were looking forward and thinking about potential applications for this draft genome. It's not enough just to have a draft genome. You need to have comparisons with other organisms, especially when you're working on things like human disease and other types of model organisms that allow you to model these diseases in more simple systems. The other thing they had to do was work on these sort of 5-year increments in multiple areas. So you had areas where they were working on a physical map of the genome, sequence data, informatics, model organisms, and even ethical considerations. So all of those teams had to work in a unified manner, and they had to work, over this 13-year period. And you had this long-term thinking about this project, not only in terms of implementing it, but then how people would use it in 10 or 20 years. Again, we're looking at projects and a series of goals over many years of contributions. And so this is actually a smaller scale project, but it's no less interesting from a long-term perspective. So this is commit examples from the Jupyter project. This is the medium post going to the medium post. And so this is a case study in long-term consistency. So this is the case of the QuantStack team, which was involved in creating the Jupyter visual debugger. So Jupyter, of course, is the interactive notebook that we all use for data science or for other types of programming tasks. And they wanted to build a visual debugger. So they had to spend a lot of time building out this feature. And they wanted, they had to coordinate their teams over a long period of time to get this done. Okay, so that's another smaller example of this, but no less important, is again, you want to think about, like, if you add a feature to your application, you want to think over the long term. How is this going to be consistent over the long term? There are always changes in Jupyter and the environment. There are going to be changes and challenges in terms of how things work. So if I release a version now, will it be good in 5 or 10 years? Okay, now I want to switch gears and talk about mentorship and how mentorship can help you sort of build a sustainable organization. Because when we talked about open source communities, we talked about how mentorship can help fill that gap of people who join your organization, do good work, and then leave. You always want to have people waiting in the wings to know kind of what's going on in the organization and then fill in for those people when they leave. So in a lot of the projects I've been involved in, open source projects, we have this open mentorship model. And so, this is a case where you have people who start making small contributions. And those small contributions can move along larger contributions in our projects. And so, we might set up a mentorship position where someone comes in, they get mentored by like a maintainer or a senior member of the team, and they participate in this program and they make as many contributions as they would like. Sometimes this is attached to something like Google Summer of Code, which is a paid position. Sometimes this is attached to maybe some coursework that they're doing. But nevertheless, they have this space where they can learn how to do open source software development. They can learn how to make contributions and do that efficiently. And then, of course, they can move on to maybe leadership positions in your organization. So some of the things that they can do include short talks on different technical topics. Toy projects where they try to build some prototype that isn't necessarily useful outside the context of the project, but it teaches them skills. Or other skill building tasks such as bug reporting and maintenance. Another thing you can do is have them integrate these activities into a larger project. So they can have a smaller project that they do for their fellowship or their mentorship period, and then integrate that into a larger project as they master those skills. So it might be a larger project that we're doing in our organization. They take a piece of that, work it out, and then they start to move into the space of the larger project, contributing that mentorship period code, and then, you know, it brings them up that community contribution curve that we saw many lectures ago. Third, it's important to assign when interaction is difficult. So, you know, we want to know when we mentor someone, the reason we're mentoring them is because they don't know the ropes yet. And what you need to do is you need to get people in your organization, but you can't necessarily do that unless they're trained. And it's hard to train someone on a project that's especially an open source project, where you start the project, you get new people and they have to kind of get up to speed on what's going on. So, you know, we want to know kind of how well they're doing in this integration process. In a lot of traditional training programs, people just kind of go through the ropes, they spend time around the thing, and you know, they either succeed or fail. But we don't want people to fail in an open mentorship model. We want to know where the interactions are difficult. So where is it in the project, if you have difficulties, is it difficult to continue on? So it's important to assign when interaction is difficult. So this could be, you know, you could have a problem at the beginning of your participation where you just can't get started. Or there might be a lull in the middle of your project where you don't know how to get things done. Or, you know, some other point of potential failure where it's makes the difference between being successful at your project and failing at your project. So, you know, this is something that we can incorporate into our mentorship program, help people not to fail, and retain good people by identifying where they're having trouble. And this is different from like a training program or someone who's shadowing someone else in a job, because they often can't ask those kind of questions. They often cannot maybe overcome some of those failure points. And so in an open mentorship model, the mentor assigns the broad outlines of the task and the mentee defines the details of the task. So if I'm mentoring someone on a project, I want them to do things, but I want them to find a way to do them, find their own style of doing them. And that helps them become leaders, because then they can actually think about the problem and then think about the solutions. And the mentor is always there to guide them and say, this is a good idea, this is a bad idea to pursue. They can gain the skill of being able to think through a problem creatively and ultimately become more engaged in the project that they're kind of building. So I did this like research group over the summer of 2019. This was associated with 2019 Google Summer of Code. This was development of Brainberg vehicles for neurosimulation. Got this worked into a publication in 2022. We did a preprint in 2020. And it was these 4 people here, plus myself as the mentor. The mentees were Z Gong, Jesse Parent, Stefan Varetsky, and Ankit Gupta. And they were all built their own models of Brainberg vehicles, which is this cognitive science type model robot that teaches you about cognitive science, teaches you about robotics, teaches you about information processing and agents. So they all built their own versions of this. And we worked on the problem. I gave them the broad outline of what I wanted them to do. And they kind of took their own approach. And we ended up with 3 pieces of software and some other work that was actually part of a later project. So we ended up doing this. And again, this is one of these situations where you have an organization, you want to get something done in a project, you have mentors that come in, they get funded, and they get to build things. And you give them the broad outlines of what's acceptable or what you want, they build it, and then they get the benefit of, you know, that experience, but also sometimes, in the case of Jesse, being a long-term member of that organization. So you can actually do a pretty good job training people both for their professional careers and for your own organization in this way. So the timeline for this is in 2019, we developed a problem for people to address. In 2020, we led a study group, produced an open software and a preprint. 2021 and 2022, we presented and fostered further development around the preprint. And then in 2022, we had a published version of the work, which allowed us to recruit open source maintainers for the projects, and that the virtuous cycle would continue. Although we haven't really moved on this lately. But the idea is, another project we did was on Monday's lecture, we talked about Log4j. And we talked about how that is an open source issue where you had a bunch of open source projects that had the security vulnerability, and they couldn't address it in their own projects because they were too small. They didn't have the expertise. So, you might say, okay, we might want to have a meta organization to help us kind of overcome these barriers to make our software less vulnerable. Or you could have an open mentorship program where you actually think about this problem. And then you develop a problem for people to address. And then you take some, those people will develop adversarial approaches, meaning that the approaches are rivals of one another. And the reason you do this is because you want to figure out different ways to solve the problem. You don't want to just use one way, you want to have multiple ways of solving the problem. You then can get funding for those approaches, and then have people work in a group with these rival approaches and see which ones are the best for different parts of the problem. Then after we do that sort of thing, we seek funding for maintainer projects. And then in 2023, which was 2 years after our discussion, we published a preprint on these adversarial projects and sort of how they solve the problem. So they were, at that point, it went beyond Log4j, but the idea is that you can use some practical problem in the community or in your organization. You can build a mentorship program around that. You can help people develop these adversarial approaches or this diversity of approaches. You can then use funding to get maintainers on board and things like that. And then you can publish to advertise what you're doing. And it helps people to be aware of it, about the work you're doing, for people to gain skills from that, and for your organization to overcome very practical problems. So we've been talking about building sustainable organizations. Sometimes the project has to be sustainable for the long term, has to be sustainable in a very broad scope. And so we talked about some of those examples. We also talked about how some organizations need to train people to solve practical problems, to solve problems that are, sometimes intractable without some sort of outside help or training new people. And that helps in sustainability by, making sure that you have people who can solve these problems in your organization. And it also helps people, it helps your educational initiative, so you can train people in a way that isn't just kind of a piecemeal, and it helps them succeed where otherwise they may fail. Now, Wikipedia has a way to do this as well. Wikipedia has a concrete model of this, a Wikipedia contribution model. This is published in this book, Reinventing Discovery by Michael Nielsen. This is a very good book that was published about, more than 10 years ago now. And it talks about like open science, open access, open source, and sort of how people are using those types of models to discover things like, open chemistry, open mathematics, open knowledge. And so it's a very good book, talks about some of these models, one of them being the Wikipedia contribution. So in the Wikipedia contribution model, they have a problem. So in Wikipedia, you want people to contribute to Wikipedia, you want people to contribute to different articles, but you don't want people to say, duplicate their efforts, or you don't want people to contribute garbage to the Wikipedia stuff that you're of interest. You also want people to not, you want people to actually contribute. Sometimes you have to work to get people to contribute at all because it's voluntary. And so you also want to have editors, people know how to edit things, people know how to write things, people know how to, be maintainers basically. So you need different roles in the production piece. So that's where the dynamic division of labor comes into play. The dynamic division of labor allows people in Wikipedia to sort of allow this stub or this article to evolve over time without keeping the same person on the article. So what Wikipedia has is they have, first of all, they have different categories of contributor, they have editors, they have authors, they have other people who maintain the site. And they also have this division of labor where if you have people who write the article or contribute to the article, it's a group effort. So in the dynamic division of labor, one person you might have does X amount of work, and another picks up that work and does another Y amount of work. So you start with no stub at all. You might have contributor X who writes the first draft. It gets accepted, and then contributor Y might take that draft and turn it into a better draft with new information, and so on and so forth. So you have new contributors every 2 years. There's a turnover in contributors. They can pick up with this artifact and they can contribute to it without losing any of the quality or losing any of the content. And this is helpful because in Wikipedia, again, you have contributions. You don't want to have one person contribute on a niche topic, drop the ball when they leave, and then you can't really update it. It hurts their brand, it hurts what they're doing. So being able to have people pick up where someone else left off and continue with this process, sometimes with the help of an editor, is very good. So these are something they call flexible micro contributions, meaning that they're very small contributions. They might be just, correcting spelling errors on one stub or another, or, adding a line on the stub, adding a topic, a subtopic. And these micro contributions lower the barrier to entry because if someone can do this on their own time, if they can just add a little bit of information to the stub, then anyone can really do this. You don't have to learn any special skills. The interface, of course, is very accessible to people. They just click the edit button and they can write. And of course, there's this system of editors, people who sort of manage some of these micro contributions and make sure that they're acceptable. But it allows for these flexible micro contributions to, basically make Wikipedia sustainable and go for years on end. So, the barrier to entry here is, someone who can change a single line of code just by clicking on an interface button, or make edits to a Wikipedia page just by hitting an edit button. And it's simple, and it's also very small unit of work, and anyone can do it. So this is where you want to just have as many editors as you can, or as many authors as you can, where they can, kind of cover each other's workload. So, not everyone can contribute a lot to this enterprise, but collectively people can do this. And it's all coordinated so that you don't have any problems. Then there's this idea of project transferability. So, when you transfer a project from one person to another, it raises the infrastructural costs. So the infrastructural costs are, you need to put things in place to make sure that when a project is transferred from one contributor to another, one project member to another, that this project remains consistent, that what their materials are, what they're doing remains consistent. So these kind of infrastructural costs are annotations of code, documentation, and creating contributions is easily defined tasks. Like in Wikipedia's case, they can manage this project transferability by making the contributions are easy, but there is a cost of putting that infrastructure in place. You need to have sort of a template for that, and you can apply it across the Wikipedia platform, but there's a cost for putting that in place. If you don't have a system like that, you may have to annotate your code. You may need to spend a lot of time on documentation so that infrastructural cost increases. And it helps project transferability, but the infrastructural cost is also high. So then I ask a question here at the end of the slide, which combinations of strategies in here between the dynamic division of labor and minimizing infrastructural costs and open mentorship increases the range of ideas contributed at minimal organizational cost. So what can you do to sort of increase the range of your project? Not the scope necessarily, but the range. How much can you do? How much can you transfer to other people at minimal organizational cost? So basically you want to make your project flexible. You want to make it robust to people leaving and staff turnover. You want to make it robust to people contributing different types of content, different ways, and so forth. GitHub is another good example of this, where if you use the GitHub platform, those infrastructural costs are sort of baked into the platform. And this is one reason why we use it for class assignments, is because I can implement Git and I can implement other types of things like, documentation and code review and things like that. And those tools are all kind of built into GitHub, and there's automation involved. So it lowers organizational costs. You just have to maybe have a subscription to GitHub repository, something like that. So this is the book Reinventing Discovery, The New Era of Network Science. This is by Michael Nielsen. And he focuses on open science. So, we talked about how he talks also about open source and open knowledge, but really on some of the successes of open science. And so using these examples, he talks about how openness and transparency can accelerate your time. So when you use an open approach, there's this aspect of openness and transparency, meaning that if I want to work on a coding project, I have my code available to any collaborator who wants to join in. I have it available, say, in a version controlled environment. And I have it available to people sort of upon request. So we can join in and you can, see everything that's involved, kind of how to contribute. The barrier to entry is low, the infrastructural cost is low, and it can accelerate your timeline because you don't have to wait to get people up to speed, potential collaborators. By training them, you might use say some sort of mentorship program, which kind of brings them on board, but it doesn't, it's in a way that's actually kind of connected to the project. So, if you're transparent in your open mentorship program, you can have people work on a small part of the project, and then that serves as an on-ramp to the rest of the project. So we talked about open science and some of the examples. There's, open mathematics, open chemistry, open biology, where people share protocols and things like that, open physics. And he talks about how these approaches are not only good for your project and how they can help speed up your timeline and make your project more sustainable, because you don't spend a lot of time formally training your collaborators or dealing with opaque issues, which could be solved by just having them, giving them full access to whatever it is you're talking about. But there are actually some technologies that need to be in place for this to happen. We talked about like, lowering that infrastructural cost with GitHub, with some of the automation tools that are baked into that platform. We talked about Wikipedia and some of the tools and things that are baked into that platform. But in open science, fostering openness and transparency, there are two enabling phenomena. The first is amplifying collective intelligence. So this is where, you have collaborators all over the world sometimes in these distributed groups, and you all have something to share. And when you get together and you work on a project collectively, it used to be that you would maybe work on this sort of, through the mail or something, where you would send a manuscript through the mail. The other side, they get it, they make corrections, they'd send it back to you. It's very slow. Or, sometimes you would talk at a conference once a year, so you don't really get the, real-time exposure there. Technologies that amplify collective intelligence are important for this. So you have collaborations built around GitHub, built around Zoom, built around other types of technologies where you can share those things and do this stuff instantaneously. The other is network science. So, again, this is where you have a network of collaborators. And there's this whole theory of networks and how they're valuable to teams. And so basically what happens is when you have a group of people in a team and they kind of work together, they form a network. And that network sometimes is connected in certain ways. So I might be a leader and I might be connected to my project managers, like I'm a program manager, connected to my project managers. The project managers might be connected to maintainers, those maintainers that are connected to contributors. And so there's this network that's hierarchical. Sometimes the maintainers are connected to one another, but not directly to the program manager. So there's like, connectivity in one sort of slice of the project. So, network science is important because it allows people to establish these relationships, these personal relationships. And if you establish it with other people as well, those ideas can diffuse through the network. So if I'm here and I'm collaborating with someone on the other side of the room, and then there's someone on this side of the room who wants to also collaborate, we form this sort of triangular network. And so we're all sharing information, and that's sort of our network. And then new people can be added into that network as needed, and they can all share that information. And it makes for a much more transparent system, a much more powerful system. And so in this book, he also argues that modularizing and decentralizing projects tend to make them more accessible. So again, this is not like an enabling phenomenon. This is sort of the way you design your project. You can modularize it into parts. So this might be a time where you say, I'm going to have a certain part of the project in year one. We're going to move to another part of the project in year two, another part of the project in year three. Or you can have modules that are functional. You might have a team that does like laboratory chemistry, another one that does computational chemistry, and another module doing something else. And you get together on a regular basis, but your day-to-day work is modularized, meaning that you form your own team, and then those teams get together at regular intervals to share their work. So it's modular. Okay. And then a lot of times, if you decentralize a project, so if you say, we don't have a top-down structure where there's like one leader and everything goes through the leader and, no one sees anything else, everything goes through. Sometimes some labs are set up like that where they have like a PI who, everything goes through the PI, which is not necessarily efficient. When you have a decentralized project, you might have people working on things in one part of the world, people working on things in another part of the world, and they can share things, kind of directly. There is no sort of, centralized authority or centralized repository of knowledge. And so modularizing and decentralizing projects tend to make them more accessible. That's his lesson for this. And so the lesson is for project management here is twofold. The first is that we can use these kind of design features on our own teams and our own organizations. We can think about, how much can we make our sort of project open and transparent? And what kind of benefit do we want to get from it? The other thing is, how do we design our organization or our team to reflect, some of these end goals? So how much do we want to amplify our collective intelligence? Or how much do we want to network ourselves or distribute ourselves? There are a lot of ways that we can think about structuring our organizations that kind of allow us to think of it as a network, think of it as like a collective instead of, like kind of a team. We just think of a team as like a group of people. Sometimes they report to management, or sometimes they work, together in a small group working together. We don't really think about the structure of that team very much, but it's extremely important to think about. So yeah, another word, an additional word on structures of teams. There's a lot of organizational psychology work on this, a lot of organizational work in general. And the idea is that, you want to think about the structure of your team to make it sustainable, right? You don't want to have like 2 people in a team of 5 working on everything, shutting everyone else out. You also don't want to have a free-for-all where there is no accountability between the 5 of you, and you just kind of pick things at random to do, and you kind of work on top of each other where you do the same tasks. Sometimes you don't do anything that's useful, and so you need to have some structure in your team and in your organization. You need to kind of map that structure out, not just who's responsible for what, but how they interact, how they're connected. Okay, so then this is an article by Vicky Boykus, and she's a software developer. And this is an article on what's new with ML in production. So this is where, they're talking about pushing a model to production. They're talking about deploying models to production. And, you want to be able to keep models running and some of the features of the models running. And you want to be able to see what that looks like. So they want to have, running models they can put into production. So this is an example here of the running model. You've got data stores, which is user activity data. You have a machine learning platform, which is ML feature engineering, and built ML model. Then you have a recommendations API, which is the model artifact, the channel recommendation service, new user onboards, service hits, and then a model that returns channels from user. So you have these 3 parts of the model, the running model. And then you perform online evaluation of the models as you launch A/B tests, and finally look at the production metrics. Now, we've been doing so, you have developed this feedback loop between production and our modeling cycle that enables us to update the model with new data. So remember, we have this machine learning platform at data stores with a recommendations API, and it's all passing through and it's all live. And you're trying to fix things as it goes, trying to develop things as it's running. And then you have this, you can not only let it run and update things, you can have this online evaluation of models, you can launch A/B tests, and look at production metrics. So you have this feedback loop over time. So this is where you kind of are able to update your model in real time and make it not only sustainable, but sort of in real time modifiable. So anyone who's worked with ML systems painfully knows that this is the case. Often you are not only troubleshooting non-working software components, but model failures can be anything from unexpected caching issues in production, classical software engineering problem, to data drift, which is where the properties of the model are used for prediction change. So, you're trying, you want to be able to troubleshoot things in real time. You want to be able to keep your models running. Sometimes that sort of sustainability, you have to design a whole system for doing that. So you don't have to take the models offline and fix them. So this is kind of shifting to working on releases and things that are in production. And I wanted to go over this because I think it's a nice example of sort of how to do the sort of sustainability in real time. You know, you can take a model offline and update it, but, you know, oftentimes that's impractical. Okay, so that was a segue into this development cycles for open source. So I'm going to talk about software development cycles. I'm going to talk about specifically for open source. People, you know, do development cycles and all sorts of projects, software engineering, it could be proprietary, it could be open source. But in this case, I'm going to talk about how development cycles work in open source and how we can structure them and update our software. So the last example was kind of running these things in real time, developing a feedback loop where you can update your data, update your features as the model is running. In this case, what we're doing is we're releasing models at a certain set of intervals over time. And the idea is to improve the models, improve the software, but to do this in a way that's maybe structured on a monthly or yearly cycle. Okay. So one thing I want to bring up though, is that open source is not always good for development. It's not always consistent with development. And what I mean by that is sometimes you have internal teams. Remember way back when we had that set of concentric circles where we had like the internal development team, and then the next circle was the open source community, and then the outside circle was the larger world or the outside world. So we have this concentric circle, and sometimes the things in the beginning, in the inside of that concentric circle, clash with the things in the open source community or the next rung out. So sometimes you can have teams that are doing things internally and they open source the software. And if you're not careful, you can have open source contributors kind of messing up their workflow, messing up their trajectory of development. So it can be bad. And of course, teams usually plan to, you know, keep those aspects of the project separate, but that isn't always the case. Sometimes if you don't plan well, you can have conflicts. So I asked two questions here. When is open source helpful in achieving development goals? And when is open source a hindrance in achieving development goals? And sometimes it can just be a matter of having an open source project where you're trying to develop something that maybe is better suited for a closed source team, or where you just restrict your open source team, you know, to maybe a couple people. And they just, you only have a finite, very small number of contributors that then can do most of the work because you don't want to have a lot of people contributing to something that needs to be constrained and maybe you need to get it out quickly. So, you know, I want you to think about this when you talk about open source and when you talk about developing software and having these release cycles or development cycles. And, you know, sometimes it's bad and sometimes it's good. It just depends on the project. So there are several scenarios where open source can potentially be a hindrance with respect to your development cycle. So, you know, a lot of times open source is good. We just talked about how open science can be very good for projects. You have case or innovation. You have cases where open source is very good at making things transparent and lowering the infrastructural costs. But in this case, you know, we might think about things that hinder the development cycle. So sometimes development is too rapid for some of these open source affordances. When I use the term affordances, I mean different artifacts that allow people to contribute to the project. So sometimes you're developing a project so fast that the documentation doesn't keep up. You might have a wiki that comes out of date very quickly. And even the general understanding of what's going on is very hard for people, you know, outside people to grasp. So you're going very fast and you're developing things. Maybe you're developing a feature in like, or a set of features in like a month. And you don't want people doing open source contributions to that because it's just, you know, you're moving so fast and the sort of understanding of that is so deep that no one can really get up to speed in a very short period of time and contribute anything useful. Okay. The other next issue is that missing transparency breaks the link between developers, teams, and contributors. So oftentimes, if your organization is missing transparency, and that is where you don't have clearly defined issues, you don't have shared information, you have an internal development team that basically is not open in the open working sense of the word. And that missing transparency is fine maybe for the very small closed off team, but maybe not for new contributors who might come in and try to contribute something. So there's usually a continuum between like a team of developers and the open source community. That's how we can do open source software. The open source community contributors basically understand what's going on, and they just simply need a maintainer to tell them if they're correct or not. And it's usually small fixes that they need to make, and it's all sustainable. But in this case, it's not sustainable because there's a link that's broken. The third point is that openness clashes with privacy and confidentiality. So, this is where we talked about an open data, where you have openness, where that openness is, sometimes you want to open up a data set to people to use, or you have so much openness that you inadvertently release personal data, which is a big no-no because, you don't want people to get access to that. You'll run into legal troubles. Sometimes but you remember social mores change over time. So sometimes, things that were fine to be open 10 years ago in terms of privacy, people viewed a lot of things as being very transparent on the web 10 years ago, which they no longer believe because there have been a lot of incidents where things have been abused, or, you have incidents where things are misused. And so you have to be mindful of the social mores of your time and of your team and how open your project is. Sometimes it clashes with privacy and confidentiality, and sometimes it doesn't. So then we have this, I want to get to something called a release lifecycle. So this is from chapter 8 in the book, Program Management for Open Source Projects. This is the Ben Cotton book. It's on the syllabus. And he talks about release lifecycle. So he talks about when you make releases of your software. And that could be like version 1, version 2, version 3, and so on. That you have these, you have to kind of manage what they are and sort of how to think about how to structure them. Because remember, the releases are sort of the way you communicate with the larger world. You say, here's a release 1.0, here's a release 2.0. You know that like something, people know the difference between 1.0 and 2.0. It's pretty major. But 1.1.1 and 1.1.2, there's not a huge difference. And we can use semantic versioning to think about, how significant that update is, but we want to also be able to communicate that to the public. And more importantly, we want to be able to support releases and communicate that what we're supporting to the public. So, remember, every time you make a release, you're adding work to your organization. So if you make a release 1 and then you make a release 2 and you make a release 3, you often have to support all 3 of those, right? You want to support 1 because users will at least start using 1 and they'll stick with 1. You want people to adopt 2, but maybe they don't end up adopting 3 for, until later. And so you want to support all 3 because you have users on all 3 versions. But one thing about this is that, of course, it can be very burdensome to the organization. And, you might say, okay, we'll support version 1 for a year, and version 2 for another year, and version 3 in the 3rd year. Okay, we'll just support them for the year and that's it. So, the longer you have multiple versions hanging out there, the more it's going to impact your organization's ability to, have to support them, have to spend time, managing the differences between them and everything else. So it's a burden to an organization to have massive numbers of versions for you. So one thing that he mentions in the book is it's not a matter of how long you support a version, how many versions you support. So if you have a version 1 and a version 2, you could support those for the life of the project. Because it's only 2 versions and the support is, you're not limited by support. It's pretty easy to support. But sometimes we want to make multiple versions. And so we don't necessarily want to maybe commit to the entire lifetime of the project. We might have multiple versions, but we only support them for 2 years. So, in a semantic versioning paradigm, we might only support the latest few releases of a product. And then we get rid of those old versions and we move to a new version and so on and so forth. And of course, sometimes we might release only once or twice in an entire project life cycle. So it's like we have 2 versions. It's pretty easy to maintain them. So we just have 2 versions going throughout the length of the project. And that's fine because it doesn't cost you any sort of maintenance or attention in terms of resources. So a life cycle can be defined as a set of phases. It could be alpha, beta, so alpha testing, beta testing, and then alpha testing, beta testing. So you have these phases that repeat as you move through. So you have an alpha version of 1.0, a beta version of 1.0, then an alpha version of 2.0, a beta version of 2.0, and so on and so forth. Your alpha releases are developmental releases that pass continuous integration. So alpha is not really meant for general consumption. It's just kind of a developmental release that's been tested through continuous integration, which means that continuous integration catches inconsistencies in files and large errors that will cause the program to not run. So you'll still have bugs, but they won't be that bad, hopefully. The beta version, of course, is where you get feedback from potential users. So you get the beta version out into the world. The alpha version might stay with the development team and they might test it out. The beta version is where you get feedback from potential users and you can do things like debugging and just maybe changing the elements like the UI. And so we have these life cycles where each version goes through an alpha phase and a beta phase, and this can go on for many, many cycles. And so this is these phases of the project, and so that's how you kind of manage. Basically, when you have an alpha test and a beta test of something, you can make a release, and that might take you like 4 months. So you might have a development schedule where you release something every 4 months. Or you might just wait for like annual releases and do the alpha beta cycle during that annual, right before the annual release. It's really up to you and your project. So in a support cycle, you often have to make a decision. You think back to when we were talking about Agile, we were talking about how you maybe set the agenda for how many features you might have in a certain release. So I might decide that we're going to release 3 features that we'll have a sprint for version 1.0 and we'll release 3 features. And then version 2.0 will release 2 features. Version 3.0, we might release an additional feature, but remove 2 features that are old or obsolete. So this is the thing you have to do for your different versions. And this helps you to constrain your scope of your project, but also to think about the sort of the support angle. So if I put a bunch of features out into the world, I have to support all those features, at least for the most immediate versions. And so that affects how many versions you can have in the world at any one time. That affects how much overhead your organization has to take on in terms of support. And quite frankly, you have to do your alpha testing and beta testing is a lot longer because you're testing more features. So what features do you include? Make functional and maintain. The more features you have, the more support you need. So if you have 10 features, you need support for 10 features. The longer your life cycle, the more support you need. So if you have a version that lasts a year, you'll have to support that version for an entire year at least. Then, you want to have some sort of release model so that not just that your team can catch up, which is important, or keep tabs on when the releases are going to be made so they can finish work on a feature by the time something is released. So if you want a team to be responsible for releasing a feature, you might encourage them to have a sprint where they can finish off the technical details and they get that feature done in time for the release. But a lot of organizations have a release calendar or a release based on the number of features that are completed by a certain time. Or sometimes they'll just make releases whenever. So you want to have a release model, it's like a mental model that you can provide to your customers, your users, to say, this is when we expect a release to come out. So, that's important for sort of public relations, but also for your team to keep them sort of in the mindset of when these releases are happening, when they need to sort of cut the pace on developing things. Now, when we talk about support itself, we're talking about providing technological help in limited cases. And sometimes you want to offer maybe limited support for free and long-term support for paying customers. This is up to the project. Sometimes you can just support something very informally for free. Other times you want to maybe have a forum so people can ask questions. Sometimes you want to have like a long-term support for paying customers, like enterprise users who may need more detailed support, and you can offer that as a service. And so sometimes you'll have a support phase. So you might have, like, say, someone might get a version of the product. You might give them 1 year of support for free, and then you retire that feature. So not everyone's using it, but you might say, well, we'll give you support for that feature, or if you pay a fee, so we don't have to take on the burden of supporting that feature for free. We can get money for it. So if we support it, and it's not everyone's using it, it's just the customers who pay for this support will get support, and the organization can pay for it, and it's sustainable. There's also the maintain support site, which is where they make changes, record problems to address in a new release. So this is where, when we release new versions of something, we want to offer support, but we also want to know kind of what the maintenance issues are in the next feature. So when we have support tickets for something, support is usually when you have problems that you have to address from users. Sometimes they're bugs, sometimes they're how to install something. So you get insights into what things need to be changed in the next version, but also, what things are problems for the users. Is it that they can't use the software properly, or is it that they're really kind of stuck on certain usability features or whatever? So this means that for every support cycle, we need to have a maintenance aspect where we can make changes or have a record of problems to address in the new release. So in the new release, we want to solve the problems that we see in the support cycle going forward. So this is very important as well. This is a website called end of life date, and this actually tells us about certain products and when their end of life is for certain versions. So remember, I said that you only want to support a certain number of versions. And sometimes it's a matter of supporting 3 or 4 versions at any time. And when you're done supporting a version, you give it this end of life date, so that people in the public sphere know, people in the outside world know when you're going to stop supporting a certain version. So that might mean that they migrate to a new version, or they should expect that a new version will be out that they can then migrate to, and they have a timeline for it. So end of life is important, and this is something that you can look on. You can look at these examples from different products and see how different organizations deal with this. So we have end of support for Firefox Reality. This is an example of this web browser and virtual reality headset. This is where Mozilla had this browser called Firefox Reality. And actually, a fork of this was made, and it's now it's called Ulvik. So they've continued on with this version, this product, but under the guise of Firefox Reality, it's no longer supported. So the new, Ulvik is supported, but Firefox Reality is not. And so you have, the option of moving to Ulvik and installing that, or you can just kind of retire your version of Firefox Reality, and what date you need to do that by. So you have full support for what you're using. So making this announcement on the website, on a support website, is important because it gives the outside world, or even the open source community, or the community of users, knowledge about when these dates are coming. Okay, so we go back to, kind of scheduling releases. And a lot of organizations use a schedule model. So they do their releases in certain ways that are kind of memorable to the outside world, or they kind of give a rhythm to the releases they make. So the first approach to this is calendar based. And that is that a cycle ends when a certain date is reached. It's regular timing, where, like, say, the Raspberry Pi Foundation releases things on March 14 or 3/14, which is pi, the first 3 digits or 2 digits of pi. Fedora Linux releases things on the third Tuesday of every April, so we know kind of that's the time when Fedora Linux releases things. You can also use feature-based schedule modeling. So this is where you have maybe the scope and the size of a feature is release dependent. So this is where you have a regular timing, but you basically use the criterion of every time we get 3 features completed, make a release. And then that adds to sort of this way that you can market the thing, which is to say, these 3 new releases are in this new version. Please upgrade. So this is defined by how many features you complete work on in a certain period of time. Bundle interdependent features, fewer releases to worry about, and so forth. You can use this to your advantage to make usability easier, to introduce new elaborate sets of features. And you don't have as many releases to worry about and support because you typically release your features together. And when you retire old features, you can then have a new release. And it helps you kind of naturally determine what the best releases are to support. And finally, whim-based, which is make a release whenever you want. This is a regular timing. We saw that in the example last time where we talked about maintenance of a repository project where we have this irregular schedule of contributions. And so in that case, you might make a regularly released software. You release things whenever the work is complete. This means that there's less intra-release structure to manage. You don't have to worry about like developing 3 features to get to a release or releasing things by like March 12th, March 14th. You just release whenever you get the work done. And it doesn't require your team to really kind of go too fast or, do, a lot of sprints unnecessarily. Sometimes we have milestones, which are, okay. So now I want to talk about issues and milestones. So you have 2 different things here. The first, of course, is milestones. These are points in time that define goals and major releases. These are, sometimes the dependencies determine whether milestones are met. So if you have a milestone, which is like, I want to complete this set of features by this date, you have to have the dependencies in place to get those milestones met. Then we have issues, project issues that meet milestones. So we can have issues that are built for meeting these milestones. Remember, issues are things that are on our project board. Milestones are these sets of issues that contribute to some sort of goal or major release. And so we can reuse issues for sequential releases. We can have a set of issues for like release 1, set of issues copied for release 2. So we know all the things we need to do for each release. And we can have this checklist basically where we can check off what needs to be done. So, there are a lot of things that we need to consider or, release. So we need to address documentation and release notes. We need to review release candidates, which are usually different versions of a release to improve, those release candidates. Basically where you say, it's basically alpha testing, where you say, okay, here's a set of features. Does this work properly? Usually test it internally before you release it as a beta test. Translations, meaning you can use different foreign language translations, and you can use that as a set of issues. Communicating schedules, so you can use a set of issues to communicate schedule. And you can actually coordinate your issues with the milestone of accommodating external conflicts and opportunities. So a lot of organizations that develop for Apple will develop, in sort of coordinate their releases of their versions with WWDC, which is a developer event. So, bringing it to release right around that time is always good because you can capture a lot of attention. Now, in chapter 9 of program management for open source projects, we have this issue of managing feature cycles. We want to manage features as a series of issues and milestones. We might use templates to manage features, which can be used to define scope, testing plan, contingency plan, rationale. So all these things that we need to do, where each feature just kind of fit the details of the feature into these templates and define all the things in that way. We can also have a scale and approval process. So this is where for each feature, we have some manager who decides what is included in a formal release. And this includes determining what is too detailed and what is too trivial. The next is how are features enforced. So how do we enforce that features get done, that features are completed on time for a release? And so we have a position in some organizations called feature wranglers. They can be scrum masters, they can be other types of project managers. They usually call them feature wranglers as a shorthand. These are open source leaders and centralized managers that sort of enforce the feature. So they go to people who are working on the feature and they say, have you done this yet? And then go through that template or checklist and ask whether, hold the team accountable. So wrangler just means that they're getting it together, they're ensuring that people get them done on time. And sometimes you hear the expression, organizing people is like herding cats. So this is kind of cat herding for feature teams working on features. Then the feature lifecycle. So the feature lifecycle usually goes through a proposal window, a timeline, and a completion path. And we talked about the feature lifecycle in the first lecture of the discussions unit, where we talked about someone doing open source feature development, where they start off by posting something on a feedback board, and then they get feedback from people who say, oh, this is a good idea, or this isn't such a good idea. And then they coordinate their efforts with a community manager, and they say, okay, now let's get some people involved, let's set up a timeline and a completion path to make this a reality. And so in a feature lifecycle, you usually have a proposal window for features where you solicit ideas for features. You then kind of work out a timeline to see if that feature can be included in the next release or some subsequent release, and then a completion path to go from the idea to the finished product. Okay. So we talked about features, we talked about versions. And now to finish up, I'd like to talk about the simplicity cycle. So this is from Resource Word 2005. I can't exactly remember where I got this from. But it gives us this model for sort of developing ideas and developing features and how we develop features without making them overcomplicated and impacting their utility. So every feature you build into like a product, a software product or whatever, in any release, has to have some functional utility. That functional utility is usually related to, say, usability, or if it's just a simple idea, like here's a floating icon, it floats around the background. Or like Microsoft's Clippy, which was a bad idea, but it had maybe some functional utility. You say, okay, that's my feature, and I want to put this in practice. So, just putting the feature in practice is fine, but you want to evaluate its utility. You want to evaluate how the idea can get overcomplicated, because sometimes a lot of people put their fingers on features and say, oh, it should be this, it should be that, and they make it too complicated. And it's just the utility stagnates. So what we have here in this graph is the x-axis, this functional utility, where we have functional, how functional is it? How functional is it for people? How well can they use it? And then the y-axis is detail. So how much detail is involved in this, in building this feature. Sometimes we have immense amounts of detail in a feature, and really a feature should be something that's simple. So like, something like Clippy was, it was a graphical thing that would sit in the corner of your Excel worksheet, and it would kind of say things in a little cartoon bubble. It would dance around. It's really maybe more complex than people needed. A very early example of an assistant, an AI assistant. It wasn't even AI though. It was just an assistant that kind of gave canned responses. So we have functional utility versus detail. So we start at one where we develop some idea to deliver utility. So this is where we solicit features. We say, do we want to have an AI assistant? Or do we want to have GUIs of different colors or something like that? Some feature we build in to our product. And we develop the better ideas to deliver utility. We identify the clear path to a very simple feature with utility. And so then we end up at two, which is where we have this bifurcation between this idea that it's overcomplicated and an idea that's simplified. So when we develop an idea to deliver utility, oftentimes we'll add in a lot of details. Sometimes we add in too much detail and something becomes overcomplicated and it impacts the utility, it becomes less useful. Sometimes the idea is developed and then there's a lot of detail added in, and then it's simplified from there. So you kind of see what you have, and then you say, okay, we can get rid of some of these things that were just kind of draft issues. And we can just say then that's simplified and it improves the utility as a result. So we have from 2 to 3 and 4, 3 being the overcomplicated case, 4 being the more simple case. And the utility improves, and it's going down this path of functioning utility. But what tends to happen is that when you simplify something, you lose detail. And so when you build a new version of this feature in a new version of the software, you might simplify the idea, then you might add new detail to improve the utility. And so you keep moving along this functional utility curve, simplifying the feature, adding new detail to the feature, and the utility kind of moves along. Because remember, as time moves on throughout your project, new technologies come into play, new versions of, say, like Python or some other software interface comes into play, and you need to change the features. You need to add detail to improve, to sharpen up the feature, or to make it modern, or sometimes just adding a new feature altogether and merging the old feature with the new feature. And the imperative here, though, is to go through the simplify, complexify cycle and always be in the direction of moving utility forward, improving utility until it has like the maximum amount of utility. And that's usually when a feature is perfected. And then by then it's probably time to remove it. But sometimes you can keep it around. And so, this is what we do in product development cycles. We work on different cycles, we work on different releases. We release them, we support them. Sometimes we have to, kind of develop a workflow around that. Sometimes we have to be mindful of when they're released, how long they're supported. And then we have to make sure that they're developed properly, that they have a lot of utility, they constantly reevaluating each feature, making sure that it's really useful and workable. Okay, so that's all for today. Thank you for attending, and see you next week. And I wanted to make one point about Quiz 2. So Quiz 2 is now live on the GitHub organizational repository in the project board there. You'll see on the organizational repository the projects. There's a project board you click through and you follow the directions that are in your forked repository under the Quiz 2 folder. Remember, you can't complete the assignment there. You have to go to the organizational project board. And then once you do, you create your issues. You then, once you create those, you can then you just create the issues. I'll get a message that you've done that, and then you classify them in the board, and that's pretty much the assignment. Just follow the directions. And so that's due next Wednesday. I signed that last Wednesday. So please be mindful of the deadline. Because pretty soon we're gonna be hitting reflection 4, and then we're gonna be getting into our final papers and presentations. So see you next week. Have a good week.